Hi, this is Mr. Bledsoe, and in this video series I'm showing you some strategies you can use to solve word problems when you're stuck. And the word problems that we're looking at are all from the North Carolina Math 1 EOC, the 2016-2017 released items, and there's a link to that PDF below the video if you don't already have that. And in this video we're looking at problem number 2. And so the first thing I usually do is I'll just do a quick scan of the problem, and I can see on the paper here that I've got a graph of a straight line that's shaded underneath, which tells me that I'm probably looking at some type of inequality. All the shaded points represent points that are less than the value of the graph there, the value of that straight line. So something about inequalities, and as I look at the answer choices I've got there, it's something about pounds of apples and pounds of oranges. So, okay. So I've got something about, I think I've got something about inequalities. Let me just write that down. Inequality and something about, let's say, apples and oranges. Okay. So let's go ahead and read the problem. It's just one sentence. In fact, the sentence is just the question that I'm supposed to answer. What scenario could be modeled by the graph below? And then it has a picture of this graph here. Okay, so again, I see that the graph is this. It's a graph of an inequality. There's my shaded part right there. I'm thinking there's going to be a less than sign involved in here somewhere, because all these points here, since they're below the line, that tells me that it's something less than the value of the line. Okay. If I could come up with the actual equation for that line, that might be useful somehow. And I notice it crosses the y-axis at 5 and crosses the x-axis at 2.5. Okay, let me see what the scenarios here that are described in the answer choices. The number of pounds of apples, y, minus 2 times the number of pounds of oranges, x, is at most 5. That's answer choice A. And I noticed that all the other answer choices, they're all different, but they all have that same kind of, that same wording. Answer choice B says the number of pounds of apples, y, minus half the number of pounds of oranges, x, is at most 5. Okay, so all of them, the number of pounds of apples is y. So y, apparently, that's pounds of apples. And x is pounds of oranges. I'll just go ahead and write that on my graph here. And since they all say that same thing, y is the pounds of apples, x is the pounds of oranges. Well, I'm wondering if I could write each of my answer choices, instead of having them written out using English, the way they're written on the paper, I'm wondering if I could write them as equations, or maybe as inequalities. And then if I had that, and if I could come up with the inequality that matches this particular graph right here, well, then maybe one of my answer choices will match that graph. Okay. All right, so I'm going to start with my answer choices. So let's see. A, it says number of pounds of apples, y, minus 2 times, oh, this isn't looking too hard, y minus 2 times number of pounds of oranges, x, so 2 times x is at most 5. Okay, I'm not sure how to write that. Is that supposed to be greater than 5 or less than 5? This looks like a less than inequality, so maybe it's supposed to be less. I'm not sure if that's supposed to be less than or greater than, so I'm just gonna write it as equal for now. I'm gonna say equals 5. Because the line itself is the equals part of the inequality, and the shaded part, it would be the less than, or maybe greater than, I'm not sure. But I'm just going to write that as equal, and I'll come back and change that later. All right, so that's A. That's my answer choice A. All right, B, I want to write that as an equation. Let's see. Number of pounds of apples, y, minus half the number of pounds of apples, 1/2 times x, is at most 5. All of these say at most 5. Let's see, C, number of pounds of apples, y, minus 2 times the number of pounds of oranges, y minus 2. Isn't that what I've got for x? Oh, y plus. Y plus 2x, and D is y plus half pounds of oranges is at most 5. Okay, so I've got my 4 scenarios written as equations. Technically they're supposed to be inequalities, but again, I'm not going to worry about that right now. And if I can figure out then what this, the equation for this straight line here, and if it matches one of these, then I'll be in business. Okay, so let's see. I've got a straight line. I notice it has a y-intercept of 5. Y-intercept is 5. And let's see, it's got a slope. The slope is negative something. I can tell it's negative because it's going in that kind of opposite way. So the slope is negative. I wonder if I can figure out exactly what the value of the slope is. And I think I can, because I can just read it off of the graph, because I noticed that the straight line actually crosses right over some of the hash marks that you can see on the page there. So it actually crosses this point right here, and it crosses this point right here. So if I start here at my y-intercept, I go down 2 over 1, down 2 over 1. So that's down 2 over 1. My slope is negative 2. Well, I've got a slope and a y-intercept. I can use the slope-intercept form of a straight line, and I can just plug in my slope and my y-intercept. So y equals, slope is negative 2x, plus the y-intercept, which is 5. And so I have y equals negative 2x plus 5. So I have the equation of this line. Again, I've written it as an equation, and I know technically it's an inequality, but again, I'm going to kind of ignore that for now. Y equals negative 2x plus 5, and that doesn't match any of these. Okay, but this isn't written. Oh, so none of these are actually written in this same form. Okay, how about if I rewrite this so that I've got 5 by itself, and then maybe it will match one of these over here. So if I want to get the 5 by itself on this side of the equation, then I want to get rid of the negative 2x and have it over here. So if I add 2x to both sides of the equation, add 2x, then my 2x's go away on this side of the equation, and I've got y plus 2x on this side, and I've got 5 on this side, and boom. That matches answer choice C. All right. So let's take a look at some of the problem-solving strategies that we used to go about solving this problem. One of them was that as soon as we realized we were working with linear functions, this is the graph of a linear inequality, we could immediately bring to bear all of the things that we know about linear functions. For example, we know that the slope-intercept form of the equation of a straight line is a very useful way of writing that line. And so once we got this into the form of into a slope-intercept form, then we could use that to compare to our answer choices. Second thing, notice that we were translating the words, our answer choices, they were all given to us in these kind of, fairly long, sentences. The number of pounds of apples, y, minus 2 times. We translated each one of those English expressions, each one of those expressions in words, into math notation. And by doing that, we were then able to compare it to the math notation that we came up with for our equation of this straight line over here. Sometimes translating the English words into math notation, sometimes that can be a little challenging. In this particular case, it was fairly straightforward because the way that the answer choices read, really all we had to do was just write down what it was saying to us. It was giving it to us in words, and we just wrote down those words as math symbols. Another thing, notice that we didn't actually need to use our knowledge of inequalities in order to solve the problem. I could have, if I wanted to be strictly correct, the number of pounds of apples, for example, this for answer choice A, the number of pounds of apples, y, minus 2 times x, is at most 5. That should technically have been a less than symbol right here. But I didn't actually need that in order to find the correct answer choice. That's often the case, that you may not need, to have every detail of the problem in order to solve it correctly. And if you don't need to worry about, is this less than or greater than, then don't worry about it. And that's what I did. I just wrote those down as equalities. Technically, this is an inequality, but again, it didn't really matter because I didn't need that information to solve the problem. And then finally, notice the way that we went about making sense of this problem. We went back and forth from the graph to the answer choices to the writing the equation of this straight line, back and forth from this to this, from this to this, from this to this. That's a very common characteristic of the way you read and make sense of a math problem, especially when you're stuck, is that you're often going back and forth from different pieces of the problem, from the problem statement down to the answer choices, to the graph, to a chart, to a diagram. You're going back and forth and back and forth. Rarely will you ever start at the beginning of a math problem and read it straight through all the way to the end and then answer it. There's always a lot of back and forth between the different parts of the information given to you in the problem.